This video will cover the Geometry Regents exam from January 2015, questions 29 through 31. Number 29 is the first short answer question that we have here, and it's actually a proof. There's a pretty long given, but you want to make sure that you mark up your picture. It says BE and AD intersect at point C, BC is congruent to EC, AC is congruent to DC, and AB and DE are drawn. Our goal here is to prove that the triangles are congruent, and we can do this in one of 5 ways. We can either prove by side, angle, side, angle, angle, side, angle, side, angle, side, 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 and HL, hypotenuse leg, which can only be used with right triangles. So what we're going to do is start our T-chart proof, where the left side is for statements, and the right side is for reasons. So number 1, first statement, first reason always comes from the given. I'm not going to write all of this down just to save time and space, but you on your test would need to write that entire given down. Yes, I know it's annoying, there's a lot to write down, but you do have to write it in order to receive full credit. So right now, if I look at my picture, it seems as though I have one pair of sides, another pair of sides, but SS is not enough to prove triangles congruent. I need to either look for a pair of sides or a pair of angles that I could find congruent. When we have these two lines that intersect, DA and BE, I can find some angles that are congruent, forming like that little X or the bow tie, however you want to think about it. Those two angles opposite one another are congruent. So angle BCA is congruent to angle ECD. And this is because they are vertical angles. And I can't just stop there, I have to actually keep explaining. Vertical angles are congruent. So then step 3, when I look back at my picture, I now have 2 pairs of sides and 1 pair of angles. So now it looks like I have side, angle, side, side, angle, side, where my angle is touching both of the marked sides. So now I get to prove, this is a short 3-step proof. Triangle ABC is congruent to triangle DEC by side, angle, side. Number 30 says, using a compass and a straight edge, construct a perpendicular bisector of side AR in the triangle below. So here's side AR. It's important to maybe highlight this or outline it so that you don't get distracted by the other sides. So your first step is to put your center on A. And your radius more than halfway. Of AR. So again, center here, radius, say here. What you're going to do is swing above and below. Swing an arc way above and back down way below. Oops, my paper is getting cut off. Then we're going to switch. Put your center on R. Keep the same radius. And swing the arc. So I'm going to switch, same radius, swing above, swing below. Now, of course, yours is going to look much better than mine because you're using a compass. And then your 4th and final step is to connect. You need to connect those points of intersection of those 2 big, huge, gigantic arcs using a straight edge. You have a straight edge for a reason so that you can use it to connect from, this line is not where I expected it to be. Connect from one point to the other. Now this line that we have here is the perpendicular bisector. Number 31 says determine and state the measure in degrees of an interior angle of a regular decagon. Now, a decagon has 10 sides. And because this is regular, there are 10 congruent sides. So here, I'm going to teach you how to find an exterior angle. And then we'll talk about how to find the interior angle. So an exterior angle is actually just 360 divided by the number of sides, n. So in other words, 360 divided by 10, which gives us 36. But to find the interior angle, we have to subtract that from 180. 180 minus the exterior angle. So 180 minus 36 to give us 144 degrees. That's your final answer. Now the reason this works is because we have this 10-sided figure. I'm not going to attempt to draw all 10 sides here, but we know that an exterior angle is currently 36 degrees. And we're looking for this interior angle. Two angles on a straight line sum to 180, which is why we subtracted from 180. So again, final answer is 144.